Welcome to a lesson with Dr. Powell. Let's take a look at how with parametric equations, in particular, let's look at this one, x is equal to 1 plus cosine t and y equals sine t. We can find the surface area of something that's of this curve graph that's been rotated. In particular, let's look at t going from 0 to pi, and we're going to rotate around the x-axis. So the picture of this is simply a unit circle that's been shifted in the x direction, one forward. And we're looking at just the top half of this right here. So let's look at this and let's rotate this around, and the shape we get is actually a sphere. So this sphere can be thought of as strips. Strip there. And basically what we're going to do is we're going to add up the areas of all these strips. Each strip we'll think of as a tiny piece of arc length. And we take that arc length and we multiply it by the circumference of the path the arc length travels. Adding all those up actually will give us the area, the surface area of the sphere. Let's see how to do that. So we're going to integrate from 0 to pi, and we're going to have the area of one of these strips, which is 2 pi times the radius, which is just the y, so sine t, multiplied by, so that's like your r value, multiplied by a little piece of arc length, which is the derivative of this squared, which would be sine squared, plus the derivative of this squared, which would be cosine squared. And notice that this part right here is 1. So it's really just from 0 to pi of sine t right here. So to do this, we take a look going from 0 to pi of sine t, and we get cosine as the antiderivative from 0. Actually, yes, it's actually negative cosine t from 0 to pi as the antiderivative, and multiplying that by 2 pi, and plug in pi, you get negative 1, so positive 1 to 2 pi times 2 pi. Plug in 0, you get negative 1, but we're subtracting that, so we actually have plus another 2 pi, so we end up getting 4 pi. And notice that 4 pi matches the surface area formula for a sphere, which is 4 pi r squared. But notice that our radius is actually 1 based off of it being from a shift of the unit circle. Thanks for watching.